Hey everyone, today is the last video for Chapter 11. And just kind of with how we wrapped up area, we're going to be wrapping up this chapter by looking at the volume of composite figures. And so recall that a composite figure is just figures made up of simple shapes. So when we're talking about three-dimensional composite figures, we're talking about making up figures based on prisms, cylinders, pyramids, cones, and spheres. So our composite figures are just taking any of those solids and kind of stacking them up to make a composite figure. So when we're finding the volume of a composite figure, all we're going to do is find the volumes of the smaller or simple solids, and we're going to add or subtract them. So exactly like we did with area, we're just working with 3D figures now. So I'm going to use a couple different colors when we're going through these problems to hopefully make it more clear what's going on with these composite figures. All right, so let's look at our first example here. So we're going to be finding the volume of each composite figure, and then we're going to round our answer to the 10th if needed. So I'm going to grab my calculator really quick. All right, so the first figure I have here, first I'm looking at this, which looks like a rectangular prism to me. So I know my first figure in this shape is going to be my rectangular prism. So I know to find that volume, I'm always taking the area of the base times the height of the prism. So let's take a look. The area of the base here is going to be this rectangle on the bottom. So I know, let's see, what do I know? If this edge is 12, that means this is 12 also. And then this side is 5, so this side is 5 as well. So I know the area of the base of that rectangle is 12 times 5, or 60. So when I go back up here, the area of the base is 60. Now the height of that prism is the distance between these two bases, which I know is going to be this 10 inches. So the height of the prism is 10. And so I get a volume of 600. I'm just going to put a box around that so I know that's my volume for that rectangular prism. So now to get my whole figure, I'm going to add on this triangular prism here. So that's going to be this whole guy here. So again, I'm looking at a prism, so the volume is the area of the base times the height. Now in this case, I said it was a triangular prism, so my area of the base has to be for a triangle. And they don't explicitly mark it here, but this is going to be a right angle, so I can use 1/2 base times height. So I have 1/2. Now the base here, if this piece was 12, I know the base here has to be 12 as well. Now the height of my triangle in this case, right, is going to be this 10 here. So I have 1/2 times 12 times 10. And that's going to give me 60. So again, I'm going to go back here. I said the area of my base was 60. Now, in this case, the height of that prism, this prism is kind of on its side. So I have a base here in blue. And my other base is over here. So the height is going to be this 5 here, the distance in between those bases. So 60 times 5, and that's going to give me, whoops, I didn't want to put it there. The height of my prism goes here, which is 5, and my volume then is 300. So now, apologize for going off the page there. To get the volume of that composite figure, I'm going to add 600 plus the 300, and I get a total volume of 900. And in this case, it's going to be 900 cubic inches. Okay, So that was an example where we're adding two volumes together. Let's look at one where we're going to subtract it. So I'm going to go over to number 2 here. Again, we're going to round to the nearest tenth if we need to. So I have two things going on here. The first thing I notice is that I have a rectangular prism. And I know this is so dark it's a little hard to highlight it. So this prism here is going to be kind of my big figure, my outside. And so if we can consider this here, that's going to be the base of that prism. So the volume of my prism here is going to be the area of the base times the height. Again, the area of the base for this problem is going to be a rectangle, and I can see it's 25 by 30. We're given all of that information. So I'm just going to type that into the calculator, and we get 750 for the area of the base. So I'm going to go back up here. My area of the base is 750. Now, the distance between my base on the bottom and up top, here they give us the perpendicular distance is 25. So I'm going to multiply that by 25. And so when we do that, we get a volume of 18,750. So I'm just going to box that in for right now. So I hold on to that number. Now, what's happening is here is they've actually cut out this cylindrical shape out of the middle of our prism. So in this case, we're subtracting that volume out. And this new shape here is going to be our cylinder. So I know that's pi r squared times the height. So now I have pi. My radius, well, they're giving us the diameter of that cylinder is 8, so I know the radius is 4. Now the height is the same as the width of my prism. So the distance between this circular base and this circular base is the same as the length or width of that prism, which in this case is going to be 30. Now remember, we don't want to round till the very end. So what I'm going to do at this point is just do my 4 squared times 30, and I'm going to leave my answer as 480 pi. Again, we don't want to round until the very end, so we're going to leave that exact with pi in our answer. And so for the last step now, I know my volume. I'm going to take my larger shape, which was the 18,750, and I'm going to subtract 480 pi. And now, once we get this answer out, now is when we'll round. So 18,750 minus 480 pi, and I get 17,242.0, really. And that would be cubic centimeters. Okay, on to the next. Here we're going to have another example of where we're subtracting the volume out. So if I look again at my large shape here, looks like now I have a square prism here. So if I'm looking at this whole outer shape, my base down here is a square. So my volume is going to be the area of the base times the height of that prism. The area of the base is just going to be 20 times 20, which is 400. But now I notice that I'm actually not given the height of that prism. And looking a little ahead, I notice I also don't have the height of that cone. So we're going to have to do a little work here, and it's going to be using the Pythagorean theorem. So here's what I know. If I could drop down a perpendicular, I know this height of the cone would be the same as the height of the prism. So what I have here, this is the height that I'm looking for. I'm told that this side, right, this angled side is 15. And then I know I'm going to use half of that diameter, which is going to be 9. So I'm going to use Pythagorean theorem here to solve for the height. So I have h squared plus 9 squared equals 15 squared. So h squared is going to give me 144. And then I know that the H is 12. So that's going to be the height of both my prism and that cone. So I have 400 times 12, which is 4,800 for that volume. Now I'm going to find the volume of the cylinder. I know that's pi r squared h. So I have pi. Again, the volume of that cone is half of 18, which is 9. And again, we just found that height to be 12. So just like before, I'm going to leave the pi out for right now. I'm just going to do 9 squared times 12. So I get 972 pi. And again, since this cone is really being taken out of that prism, we're going to subtract to find our volume. So my overall volume is going to be 4,800 minus 972 pi. Okay, and we get, wait, something's not right there. Okay, I just noticed I made a mistake here, and hopefully some of you caught this before I did. I keep saying we're subtracting a cone, which means our volume formula has to be multiplied by 1/3. So sorry for that. I don't want to cause confusion here. So we're taking the cone out, and again, hopefully you guys picked up on this before I did. So I'm going to multiply this by 1/3. So if I go back, I have 1/3 times 9 squared times 12. I should actually have 324 pi for the volume of that cone. So now when we do our final here, I have 4,800 minus 324 pi. And now I get 3,782.1 cubic meters. So again, I apologize for that error there. All right, so we're just going to do one more example here to round out the video. Now we're back to adding two figures together to get our composite volume. So here I have, it looks like a cube actually, because all those dimensions are the same. So my volume is going to just be the area of the base times the height. For the area of the base, again, is just 12 times 12, which is 144. My height is right here. It's going to be 12. So if I get 144 times 12, I get 1,728 for the volume of my cube. Now, on top of that, we're adding a pyramid here. So I'm not going to forget my 1/3 this time. We have a square pyramid. So our volume is 1/3 the area of the base times the height. For the base, it's the same as the base of my prism here. So I have 12 times 12, which is 144. And here they're actually giving us that perpendicular height, which is 18. So if I multiply this all out, I have 1/3 times 144 times 18, and I get 864 for my pyramid. So now we're just going to add those two volumes together, get 1,728 plus 864, and I get 2,592. And that's cubic centimeters. All right, so that's it for today's video. We didn't have any with spheres in them for the video, but we'll make sure we get practice with that when you are in class tomorrow. So that's it for today. Bye.